Hi there, and welcome to the Air Equipment LLC YouTube channel. My name is Bill Dunn, and this is part 2 of our topic, HVAC noise control. When analyzing the acoustics in a building, specifically the HVAC system, it is kind of complicated, but we can break it down into 3 basic parts. The first part is what we call the source. All equipment on a job make noise. Anything that has a centrifugal wheel or a compressor or a valve will generate noise. So the first thing we need is what kind of noise energy is being emitted by the source. Whether it's an air handler or a VAV box or a return fan or a unit ventilator or a fan coil unit, the equipment makes noise and we need to know how much noise it is making. The second thing we need to look at is the noise path. Each piece of equipment that's making noise, that noise will travel away from the equipment. And the thing is, a single noise source can have multiple noise paths. So we need to look at all the paths. There can be noise that goes down the supply ductwork. There's noise that radiates outside of the casing of the unit. There's vibration noise that may go down through the floor or the ceiling into adjacent spaces. There's noise that comes out the inlet side of a piece of equipment. So there's many noise paths, and each path has to be analyzed. The third and final path is what we call the receiver. This is how the people in the space are going to perceive the noise. And that depends on the use of the space, whether it's going to be a classroom or an office space or industrial facility. The receiver is how much noise can we accept? What is an acceptable level of noise in that space for that particular use? For interior spaces, the most common measurement we use is called the NC system, or the noise criteria. The NC system is simply a series of curves, and it gives us a single number descriptor of what the basic sound level is in the space. Just a single number telling us what the average sound level is in the space. Now the NC curves are on a graph with the loudness in decibels on the vertical scale, and the frequency are 8 different frequencies starting from 63 Hertz up to 8,000 Hertz going on the horizontal scale. And these curves, as you can see, they're actually curved. They allow for more decibels in the lower frequency range, and this is because human ears do not perceive sound as being quite as loud when it's a lower frequency. This is why we use high-pitched horns and sirens to get people's attention, because we hear the higher frequency sound to be a lot louder. So each one of these curves has a number, and the ones shown on this graph start at NC 15, then 20, 25, 30. And what's done is measurements are taken in the space. We get the decibel level of the sound pressure of 8 different frequencies, and those levels are plotted on the graph. And whichever one of these curves has all of the points at or below that line, then that is the NC rating for the space. And depending upon the use of the space, we will know what NC level is appropriate and acceptable. For concert halls, of course, we need that very, very quiet. That's in the NC 15, 20, 25 range. Classrooms must be in about the 25 to 30 range. Office space can be 35 to 40. Laboratories can be higher. And of course, industrial areas are often much higher than that. Back in 2002, the American National Standards Institute, or ANSI, worked with the Acoustical Society of America to develop a standard for classroom acoustical design. And this standard is S12.60-2002. And what this standard said is that the permissible background sound levels in a typical classroom setting cannot exceed 35 dBA. Now, dBA is another system of presenting a single number to give us a weighted average of sound pressure levels. It's similar to, but not the same as, the NC. And in fact, the 35 dBA mark is approximately an NC 27. Now this is quite a change, because prior ASHRAE guidelines called for an NC level of about 35 in classrooms. So this new standard is much more stringent, much quieter. ASHRAE has always called for an NC level of 25 for a performing arts center. So the classroom design standard now is just slightly louder than a performing arts center. Back in 2005, the state of Connecticut adopted legislation which says that for any school building project authorized by the General Assembly on or after July 1st, 2005, which basically is all of them, classrooms or libraries shall be constructed or altered in accordance with the ANSI ASA standard S12.60. So in other words, our new design standard for classrooms is NC 27. This is very stringent. Any kind of device that has a spinning impeller in it, like a VAV box or a unit ventilator, now most likely cannot be installed in or near the classroom.